Now in part B, we will investigate the effect of the function of the mixer to our signal. Basically, we will use the signal that we generated in the previous steps. In the part A, that is operating at 913 megahertz. We will mix it with a tone, 10 megahertz tone that is generated from the back panel of the VSG. We will mix them by using a mixer, and then we will transmit the signal and observe it at the receiver. So as you can see, the connection, the implementation of this filter is shown here in your screen. This is the output of the back of the oscillator from the back panel of the VSG, which is connected to the L input of the mixer, and the RF signal from the VSG is connected to the R input of the mixer, and the output of the mixer is given at the port named I, which is given to the antenna for the transmission. So we can now start transmitting and observe the results at the receiver. So this is the VSG. Now we are operating in the vector mode. We can see now we are receiving at 913, but we have extra tones that we are receiving, extra signal that we are receiving. Let's try to find out the frequencies of these signals. So I will use markers. I will add marker. So the first one is at 913 megahertz, which is the operational frequency of the VSG right now. And we will add another marker. And here, so we have other two tones, as you can see, with marker 2 and marker 3. The one at marker 2 is at 900 and almost 3 megahertz, and the one at marker 3 is 923 megahertz. If you can investigate this one, you will observe that these extra tones, the harmonics that we are receiving, are exactly at 10 megahertz from the fundamental tones that we are transmitting. So simply we can understand that the function of the mixer is to down convert or up convert the center frequency of your transmitting signal to a new one, to a new the center frequency. Like in this case, instead of we are receiving at the 913 as well as at 903 and 923 megahertz. So in the manual, we are also required to perform the demodulation at this harmonics that we are receiving. So I will let's try to demodulate the one at 903. So I will receive here, change the receiving frequency to 903 megahertz, and then I will switch to the digital demodulation mode, and I will set up demodulation tools. Let's remove the markers. So you can see this is the signal that we are receiving at 903, which is the harmonic produced by the mixer, and it exactly contains the signal that we are transmitting. As you can see, the demodulation is perfect. Again, we can also observe the same thing from the harmonic at 923 megahertz. Again, we are receiving what we are expecting. So that means if you have you are transmitting at a particular frequency, but you want to receive at a different frequency, that means you can use a mixer to change the center frequency of your signal to another frequency, so that you can easily receive at that particular frequency that you want. In this last section, we will observe the effect of the VCO on the system. This is similar to the previous section, but the only difference is that instead of using the 10 megahertz oscillator that is provided at the back panel of the VSG, we will use the VCO to generate a tone with a controllable frequency, and we can control the frequency of this tone by just adjusting the input voltage to the VCO. So to do this, we first of all we need the two DC power supplier. One for them is for the biasing voltage, and one of them is for the controlling voltage of the of the VCO. So as you can see on your screen, the connection is like as shown. The output of this from this power supply will be connected to the biasing pins of the VCO, and the output from this one will be connected to the control voltage of the VCO, and the output will be connected to the mixer that will mix the signal, the tone generated by the VCO and the RF signal from the VSG, which will be given to the antenna for the transmission. So in the first case, we will switch off the transmission from the VSG. That will be only observing the tone that is generated by the VCO. So I will turn the power supplies on. The biasing voltage for the VCO is 12 volt, and the voltage from the power supply we will be adjusting it based on the frequency of the tone that we want to generate. So now let's say we want to generate a tone by adjusting this. Let's say we set something like 10.5, for example. We can see as we adjust to 10.5 here, we can observe a tone here at 912 megahertz. We have a tone here, and when we change this frequency, when we change the voltage to 10.7, for example, we have the tone shifted to a new frequency, which is 918 megahertz. So we can see, and as we increase the frequency, the voltage of the power supplier, we also increase the frequency of the generated tone. So you can take a screenshot for these two cases alongside the voltages that we used to generate them, and put them in your report. Now let's try to generate a tone by using the VCO that will down convert the 913 megahertz signal that we are generating from the VSG to 200 megahertz. And to do that, we need to do a simple mathematics that in order to have a signal at 200 megahertz, that means we have to take 913 megahertz minus 200 megahertz. That means we need to generate a tone at 713 megahertz from the VCO. So we can go now to the VCO, to the transmitter, so that we can do some adjustment here. I will try to observe a tone at 713 megahertz. At this point, my VSG is still off, the RF is off. So I will try to see if I can generate a tone by using the VCO at 313 megahertz. So I will play with the voltage until I get that a tone at that particular frequency. So you can see I'm starting getting something here. I'm getting something. Here it is coming. Yes, this is exactly what I want. Let me increase the averaging. Let's say 100. So you can see now I have it on at almost 713 megahertz. So now I will turn the VSG on. So I am expecting with this 713 megahertz tone from the VSO, it will down convert the signal that is coming from the VSG to the 200 megahertz center frequency. So let's go to 200 megahertz and see if we can observe the signal that we want. So you can see here we are receiving something which is exactly at 200 plus something because of the tone that we generated by using the VSO was not exactly at 713. So as you can see, we can use the VSO to convert the center frequency, the carrier frequency of the VSG to another desired carrier frequency.